Having said that, the concept was simple. We have Miss Anjali here, we have Mr. Rahul here, and you all know Anjali was able to send some message, right, to Mr. Rahul in the form of, or basically you can say she knows some algorithm. She was doing encryption, and that is why this guy was not able to read all these message. And this guy is Mr. Intruder, and now he is quite frustrated. What he wants is that if he cannot read the communication, if he cannot read the messages between Anjali and Rahul, at least he can destroy the conversation. And that is exactly what it is doing, right? He's taking this encrypted message, he's changing them. And when these messages reach to Mr. Rahul, when Mr. Rahul decrypts these messages, he sees some messages which are not understandable at all. He is calling Anjali that Anjali, your messages are not making sense. And Anjali is saying, I am using the same algorithm. I am using the same key which you have, and I'm not sure what is happening. So Mr. Rahul is thinking aloud, and he's thinking that there is somebody in the middle who do not want that we can communicate with each other. And Mr. Rahul want to be absolutely sure that if there is somebody who is changing Anjali's message, Mr. Rahul want to know, right? That if the message is changed or not. If the message is changed, Mr. Rahul is going to ignore this message. As simple as that. But how come Mr. Rahul, right, will come to know whether the message is changed or not, whether the message was originally from Anjali or somebody is sending this message on behalf of Anjali after changing it. Interesting, really, really interesting. And that is where the integrity of message comes into picture. What we are trying to do here, we are trying to maintain, manage, right? We are trying to make sure that the message integrity is same. We are trying to make sure that the message is not changed during the conversation. And that is where I will be taking you to the next part, because if we want to achieve integrity, we need to understand some basic concept from the life. And believe me, most of the security concepts, most of the things, right, in security are taken directly from the real life. Don't believe? Just see an example. We have Miss Anjali once again, and here is the fingerprint of Miss Anjali. What is the meaning? The meaning is simple, that this fingerprint is actually the identification of Miss Anjali. Why? Because no two person, no two different human being can have the same fingerprints. You all must know about it, right? If that is the case, this fingerprint is actually the identification of Anjali. Try to remember, we are trying to achieve integrity while doing communication, right? And because we want to achieve integrity, we are learning a new concept, right? And I'm calling it as a fingerprint. So if I want to use this fingerprint, I can take any document. And Anjali, if she put her fingerprint on this document, the meaning is that Anjali has read this document. And Anjali is so sure about it that I have read it, and I am marking it that I have read it. Or maybe this document is created by Anjali. This is the full proof because Anjali has signed this. Anjali has put her signature on it because her fingerprint is kind of her signature. You all know in today's world we use fingerprint in many data center. If you want to take entry in the data center, right, at the entry gate, you can see there are some security mechanisms through which if you want to pass through them, you need to provide your fingerprint. And if you are a proper employee, if you have the access of data center, then you can go inside. And there are so many security systems in this world with who are working on this principle, maybe on the fingerprint or the biometric also. But now here is my question. That is fine. In case of physical person, we know that we have fingerprint. But what if in case of data, in case of file, because this file is virtual, right? Nobody have seen all these ones and zeros, right? Which are communicating between Anjali to Rahul, and how we are going to make sure that we can put some fingerprint on top of it. So does a file can also have a fingerprint? And the answer is absolutely yes. We can develop some mathematics. As a result of that mathematics, we can generate a number which is the result of this file. What is the meaning? Suppose I have a box here, and the important property of this box is that it takes a file content or a file as an input and produce a number. And this number is something like 10011, right? And the property of this box is that doesn't matter right? If you give the same content to this box, it is going to give you the same result, the same result. But if you change anything, any content of this file, maybe if you change only this comma with a full stop or anything, even a single change, if you do, this box is going to change this number, the total number, it is going to change. So can I say that if my file remains same, this box is going to produce always the same number? I can say this is as good as fingerprint of my file, right? In nature, basically we all have fingers and that we all have fingerprints. It is a unique or identification of individual, right? But in computing world, we can just mimic this situation with the use of this box. What inside this box is or who has created this box, maybe it's a different discussion together, but we can believe our mathematician that they can generate this number out of a file so that if you do not change the file content, this number is going to be same if you pass it through a box. So this is the fingerprint. It is as good as that this is the fingerprint of this file. We can attach that this data is always going to produce this result if we pass it through the box. As simple as that. Just keep this board in somewhere in your back of your mind, right? Maybe in your subconscious mind. It should be there. But now, what is the use? The use is we are going to understand in the next board. Very, very simple. Let's see it here, right here. So, what is happening, guys? As I mentioned that we, Anjali, want to send a file and we are not talking about encryption now, right? And if you are not talking about encryption, then what I'm talking about, see, suppose I have a check and I have written that I want to give 10,000 rupees to Mr. Rahul. And here is my signature. Maybe Anjali is writing this. You all have seen this kind of document, right? Check, the bank check. Although most of the transaction happens today in the form of digital world, but still we use checks and checks can be seen by anybody. Anybody can see the content on this check. 10,000 rupees is going to Rahul and Anjali has signed this document. Now here the point is not to secure the document, not to encrypt the document. The point is that this check is signed by Anjali because nobody can forge Anjali's signature. As simple as that, right? So try to understand. Here, right now, in this board or maybe coming board, we are not trying to encrypt the document. We will include encryption. But my point is, can I send document with my signature? Just like the document or the check with Anjali's signature, can I replicate the same thing in computer world? Why? Because right now I'm learning the tools. I will be using this tool to understand TLS, to understand IPsec, to understand identity services engine also, right? So Anjali want to send this plain text file to Mr. Rahul. And as I mentioned, that there is going to be a box, which is known as the black box. If you pass this file content to this box is going to give me this result. And I can mention that Mr. Box, you can please generate the result as 256 bits. This number should be no longer than 256 bits. It means that whatever your file is, this number is also always going to be 256 bits. But those bits are same or different, that depends on the file. For example, if you send the same content like, hi there, how are you, enjoying learning security? If you're passing the same content to the box is going to give you this result, only this result. But if you change something, maybe instead of E, you write A here, this number is going to be totally changed. Maybe this time 1111000, maybe. Interesting, right? And we call this, and we call such box as a function because it is doing some function. It is taking input, it is changing that into output, and it is doing this function of changing input to output, changing input to a fixed output, right? And in security, we call such function as hash functions. Hash functions are always one way. What is the meaning? The meaning is if you have a file here, you can generate a value from this file by passing this file to this hash function, right? But if you have this value, you cannot generate the file again. This is the only property of the hash function, that it is going to be always one way. If you give it a data, it is going to give you the output in terms of a number. But if you give the number as an input, it is not going to produce the file. Believe me, it is not like encryption and decryption, right? It is slightly different. That encryption is two-way. With the help of a key and algorithm, you can encrypt the document, and with the help of the same key and algorithm, you can decrypt the document. But here, we are just producing the fingerprint of the file. Whatever is written in the green color, it is as good as that it is the fingerprint of this file. If you have heard about SHA, secure hash algorithm, or MD5, message digest 5, these algorithms are just like this box. These are known as hash algorithms. And I'm absolutely sure that in your career you must have heard about SHA and MD5. If you do not know much about network security, still you must have heard about SHA and MD5. As simple as that, right? So we understand SHA is there. It is a one-way function. It can produce something, some number as a result of this file. Now, this file can be in India, and you can take this file from India to US in a flight, right? If the content of this file is not changed, right? And you are passing to again to a same hash function, it is going to produce the same number. But if the content is changed while the motion, maybe somebody has taken that file, changed that file, and if you're passing it to again the hash function, it is going to produce totally different result. Believe me, this is the most important property. If we change anything in the file, the number is going to be changed totally. The fingerprint will be changed because now the file is different. Okay, interesting. Now, let's see how we are going to use it. So I am going on the next board. If we have understood previous two boards, believe me, it is going to be an interesting discussion. So what is happening here? We have Anjali. Anjali wants to send this document to Mr. Rahul. Anjali is hashing the document. The meaning is Anjali is passing this document to the same box in which we have this time SHA. SHA means hash algorithm. It means that it is going to produce the fixed number, this number. If this file remains same, this number is going to be always same. It means that this number is actually the fingerprint of this file. Now what Anjali is sending over this internet? See, we are not trying to encrypt it, guys. It is as good as I am sending my check, right? I have signed this check, so intruder can see this. There is no doubt about it. Intruder can also see this. But the point is that if this document reaches to Mr. Rahul should be sure that whether this document is forged, but whether this document is tampered by some intruder or not. So what is going to happen? This document, the complete thing will be reaching to Mr. Rahul. Mr. Rahul will be separating them. He is saying this is the file and this is my hash value. Mr. Rahul knows that Anjali has used SHA algorithm when she was at her place. So what he is doing, he is taking the file, he's taking the hash value by passing it to SHA, and this is going to give you some fingerprint. If both these value match, it means that this file is not changed. This file is exactly same as this file. If that is the case, Mr. Rahul is so sure about it that yes, nobody in the middle has changed this document. As simple as that, right? Interesting. Now, suppose what is going to happen if suppose this intruder is taking this document and he's changing this message completely, or maybe little things in this message. If that is the case, what is going to happen this time? Now, intruder is sending this on behalf of Anjali after changing this message. If that is the case, this message will be reaching to Mr. Rahul. Mr. Rahul is separating it here and here. Now the document is changed. If that is the case, we have sorry for this, we have fingerprint right here, and we have Mr. Rahul is going to pass this to hash, the same SHA hash, means secure hash algorithm, and it is going to give a result. And of course, we know that if there is a slightly change, or if there is a slight of change in this file, the hash results are going to be totally different. Maybe here the result is going to be 101111, and if you compare both of them, those are not going to match. And if those are not going to match, then it means that the document is forged. The document is changed by somebody. Really, really interesting, right? But now you must be thinking, if you know the security well in advance, then you must have thought a flaw in this complete communication. And what is that flaw? I am talking about it. See, as I mentioned, that if Mr. Intruder changed something in this file, Mr. Rahul is going to know because this hash value is going to be different than whatever Anjali has attached. Now, Intruder is one level next guy, right? He's the next level guy, you can say. If that is the case, what is he doing? See how intelligent or how clever he is. He's saying, I will change whatever I want to change in the document. And I also know that Anjali is using hash. So he will be changing this hash value also. After changing the document, he is going to pass this document to the same hash algorithm, which is SHA, secure hash algorithm, which is going to give it totally different signature or fingerprint. And now what is he sending? He is sending the changed file and change fingerprint also. He is the next level guy. Believe me. If that is the case, what Mr. Rahul is going to do? Poor Rahul is going to separate the file with this guy. File is also changed and this number is also changed accordingly. If that is the case, the hash is going to be same as this number because of the trick done by Mr. Intruder. If that is the case, these two numbers are going to be same. Mr. Rahul will think that the same message is sent by Anjali. Interesting, right? This is really bad. And you must be thinking, Mr. Vishnu, you told a solution. You just recommended a solution. Use fingerprint. And now you are saying that your solution can be breached by Mr. Intruder. Believe me, the innovation happens like this. Somebody created a solution, somebody else is going to break it, and then you are going to create another one, which is more advanced than previous one so that it cannot be break, right? Sorry, it cannot be broken. Now, what Miss Anjali is doing so that Mr. Intruder can't do such things, let's see. Let's try to understand. So, as you all know, in mostly communication, although I am still not incorporating the encryption portion, but I am just including an encryption key. As you all know, yesterday we discussed about symmetric key encryption, right? You all know that. In the symmetric encryption, the two parties must have the same keys. And believe me, I have this key. Suppose this key value is maybe 1, 2, 3, 4. Do not get confused with this picture or this symbol. Although this is a key symbol, but at the end of the day, this is just a number. The same secret key should be there with Mr. Rahul if they want to encrypt and decrypt each other message, right? But believe me, we are not encrypting and decrypting using this secret key. Now, what Anjali is doing, it is remarkable. Anjali want to send this message, hi there, hi, how are you? Enjoying learning security? Absolutely, we are, right? So along with this, she is, along with this message or along with this file, she is introducing one more line, which is 1, 2, 3, 4, which is the secret key of Anjali, which is known by only Mr. Rahul and only Miss Anjali. Instead of creating a hash function of the data, she is creating a hash function or she is creating a fingerprint of the value or the data or the file plus this key, which is 1, 2, 3, 4. Interesting. She's passing these two values in one-way hash function and the value is this, suppose. Really interesting. Just keep in mind that we are changing our approach. We are not encrypting the data. We are just using key because I know this is only with me and with Rahul. This 1, 2, 3, 4 number is not with Mr. Intruder because secret key is with Anjali and secret key is only with Mr. Rahul, right? I am doing hashing with data plus secret key, which is going to give me the new fingerprint. And now let's see how we are using these fingerprints. It is going to be an interesting discussion. So just give me 5 minutes of time to complete this. Once we are done with this, I will open this forum for questions. You can ask any question. See what I'm doing right now. Miss Anjali wants to send this message to Rahul. So what Anjali is doing? Anjali is taking her secret key along with this message and hashing it. So this will become the fingerprint. This fingerprint is not of the file. This fingerprint is of its file plus key value, which may be 1, 2, 3, 4. Suppose. Now, instead of sending this message along, this message or this file, Anjali is sending this file, only file, not the key, guys, right? Anjali is sending only this file and this fingerprint, whatever has come here. Interesting. I'm not bringing Mr. Intruder into picture. I want to understand what is going to happen. So file will be reaching on the internet, and from the internet it will be reaching to Mr. Rahul. Mr. Rahul is separating the file and fingerprint. Now we have this file, and of course, if we want to have the same hash value, we should be having the same key. And also, of course, Mr. Rahul is having the secret key. Rahul is going to take the secret key, which is 1, 2, 3, 4, and have this file plus secret key. So we have file plus secret key here. We have file plus secret. We had file plus secret key here, right? If we pass it through the same hash function, I am going to get the same value, right? And I am getting this value here. And of course, I am getting this fingerprint here. If I combine both of them, or if I compare both of them, these are going to be same. If these are same, then Mr. Rahul is absolutely sure about it that nobody has tampered this file with. Really, really interesting discussion, guys. Let's introduce Mr. Intruder also. Now, Intruder is taking this file. He's changing some of the content, right? But he doesn't know. He's thinking that this file is having this signature, but the signature doesn't belong to this file, because at the start, to begin with, Anjali has used this file content plus her own secret key. And Mr. Intruder didn't have that secret key. If that is the case, he can change it. If he can change it, this number he can also change. Just like in the previous board. If that is the case, Mr. Rahul is going to, now this message is going to be sent on the behalf of Anjali by this Mr. Intruder. This file will be here and the fingerprint will be here. Mr. Rahul is going to attach the secret key and then passing it to the hash value. And of course, these two values are not going to match. Very, very interesting. Just try to understand it. If these are not matching, Mr. Rahul is absolutely sure that there is Mr. Intruder who has changed this file. And if Mr. Intruder has changed this file, Mr. Rahul is not going to believe it. By the way, we haven't still considered encryption in picture. Why? Because we are just sending a check signed by Anjali, which can be seen by everybody, right? But now still, if it can be seen by anybody, it doesn't mean that anybody can change it. That is exactly what I'm doing. Anjali is sending a file which can be seen by anybody, Mr. Intruder too. But if Intruder changed that file, Mr. Rahul immediately come to know that somebody else is sending this message on behalf of Anjali. With that, we are at 30 minutes now. I would encourage everybody here, please do ask your questions. Anyone? Okay, at least tell me, am I audible?
Yes, Vishnu.
Perfect. So raise your hands and ask as many as questions as you want. Anybody? Questions, please. By the way, in Hindi class, there were so many questions. Mr. Abhishek.
Yes,
Yeah, Burak. Please go ahead, Mr. Burak.
Sorry, may I ask?
Yeah, please go ahead.
Without hand raise? Thank
Please
you.
go ahead. Yeah.
How do they share the shared key securely?
We will be talking about it. For this board, just try, just understand that the secret key is right there with both of them. See, I'm again saying I haven't completed the picture yet. We are just learning the tool. We have learned confidentiality. We are just learning integrity. Once we are done with the authentication, I will combine them, add some more things, and then you can see how these keys are getting exchanged. Mr. Burak, do not worry about it.
I see. Okay. Thank you.
Yeah. Mr. Abhishek, I think you had a question. You raised your hand. Please go ahead.
Yeah, hi, good evening. So that only the my how come Rahul knows about the secret keys? It is same with that.
I will be talking about it. Anybody else? Any doubt? Any question? Mr. Augusto, Daniel, Krishna, anyone?
Yeah, I have a question, but I still have doubt of
How to raise the
uh,
hand, right? I think.
uh
Please go ahead. First, ask your question.
yeah. No, I still have a question about um the first key exchange.
We will be
The
covering it. Do not worry.
okay.
The first message or the second
Yes.
message in the TLS does that. Once we are talking about TLS, we will be talking as I mentioned. We are just learning the tools. Have them in pocket.
Okay. Okay.
We need them when we try to understand TLS. Okay.
Okay.
But if we forget about it, that how this key exchange happened, if the key is with these guys, right, Anjali and Rahul, so I think you all are on the same page that this way my message integrity can be saved, right? I think yes. Anybody else? Questions?
Nothing, Vishnu, as of now.
Perfect. Now the question is, why have you written Mac here? So by the way, whatever we have, whatever the codes we are generating, whatever the fingerprint we are generating here with the use of Miss Anjali's secret key, this is known as message authenticating code or message authentication codes, right? This is not the MAC or the MAC address. These are message authentication code. Right now, we are just sending this check. But what if I want to send my message encrypted? But before that, Mr. Abu Bakr has question. Please do ask your question, Mr. Abu. Please go ahead, Mr. Abu. I'm not able to hear you.
Yes, sir. Yes, yes, sir. I mean, my question is, I mean, from Miss Angeli,
Mhm.
I mean, the file and then the key. I mean, it gets hashed into the code 111001, right?
Yeah.
So why, I mean, am I still seeing, I mean, another file when it's being transported to Mr. Raul? I'm still seeing the file.
Oh, you are
There
still.
is a file and then there's a key right, I mean, beneath it.
Mhm.
Yeah, I'm trying to think. I don't know if I'm thinking outside the box though, but I was expecting probably, okay,
See,
probably,
you
yeah,
do you agree, Mr. Abu, that secret key maybe, which is 1 2 3 4, is also with
yes,
Mr. Rahul? You agree with me?
yes,
Now
yes,
try to understand. Miss Anjali know that she has the key. Miss Anjali also knows that Mr. Rahul has the key. And Miss Anjali also
yes,
knows that the intruder or anybody else is not going to have this key. You agree with me?
yes,
Now, there
yes,
is a
I
trick
do.
which Miss Anjali is playing with, right? She is saying that instead of hashing my value or the data, I will hash what the data is, which is going to go on the internet, and what I and only Rahul have. So she combined data plus 1 2 3 4, which is her key. And then this
Okay,
she gives this thing to hash algorithm, and then she generated this number 1124. Suppose this number is the hash. Okay.
okay,
Now she's sending only data. Now here she is not sending the secret key. Get my point? She's sending
yes,
only data and this number 1124, which is the fingerprint, not of this
okay,
data. This was the fingerprint of data plus key,
neither.
right?
Okay,
And now, if you want, so what is going to happen? Now Rahul will be taking this 1 2 3 4 here, right? And the file here. But the problem is, if Mr. Rahul has this file only, he is going to get entirely different result. He will be getting the same result only if he combine this data plus his own secret key, which is exactly same as Anjali. So data plus this value is going to be same. If this is same, it is going to produce the same hash results,
okay,
right?
yes,
Perfect. And believe me, as many guys here were saying that we were not able to understand TLS or SSL or nitty-gritties of IPsec. The whole sole reason is if you go and directly read TLS without these concepts, believe me, it is going to be one of the hardest topic to understand. But if you get this little concept, which are really, really easy, TLS, SSL, IPsec are going to be piece of cake. Okay. Let's talk about another question from Mr. Patil. Prashantji, ask your question.
Yeah, Shnuzi. So is my understanding is correct or not?
Mhm.
So here we are generating this value, maybe it's a digest value by using the data plus hashing algorithm that may be MD5 or a SHA
Mhm.
plus that key.
Yep.
So is that correct?
You are right.
Okay. So the receiver, so he will also use the same key and same algorithm
Yep.
and the data whatever is using. So once he generate, if that matches, so that means we'll come to know, okay, the data is not altered through the path.
Yes, you are right.
Oh, yeah.
Absolutely.
Mm.
Okay. Now, let's talk about. So, right now we have just sent a check. Next topic is suppose I want to send now data. I am not interested in now sending the check. Mr. Burak, could you please be on mute? Mr. Burak. Okay. So, right now, in the previous board, we just sent a check which is signed by the Anjali, which can be seen by anybody. But if anybody tweak this check or forge this check or do anything on this check, Mr. Rahul came to know about using the message authentication code. But right now, we are not sending the code, check. This time, Anjali want to send a message to Mr. Rahul securely. Means encryption is going to be there. And she wants to make sure that when the message reaches to Mr. Rahul can check whether this encrypted message, whatever he has received from Anjali, is tweaked or not by this Mr. Intruder. It means that now I am talking about encryption as well as integrity. I am combining both of them together. This is one of the most critical pieces in TLS. Try to understand it. Now we are not sending the check. We are sending the data which Anjali wants that nobody should read. It means that confidentiality or encryption will be coming into picture. And Anjali also wants that if Mr. Rahul receive this, Mr. Rahul has the proper mechanism to check whether this data has been altered in the middle or not. I need your 10 more minutes of complete concentration. What is happening here? Anjali has this file. Actually, she wants to send this to Mr. Rahul. And suppose we are talking about a symmetric key encryption. It means that Anjali is having a key, maybe 1, 2, 3, 4, and Rahul is also having a key. Sorry for this, which is 1, 2, 3, 4. Suppose. Now, really interesting. We have this message right here. What Anjali is doing. First of all, Anjali is passing this message which she wants to send to Mr. Rahul, right, to a hash function. Maybe this function is SHA, secure hash algorithm, and she is getting this fingerprint, right, or the number, which is also known as fingerprint or message digest. See, this is, so if I'm calling it as a fingerprint, I'm calling it as a number, right, or digest. Everything is same, right? So right now I am getting this fingerprint here. Now Anjali is combining the file plus this fingerprint. Now this is the data which Anjali is going to send. Because this data cannot be read by anybody, she wants total privacy. She is using an algorithm, maybe encryption algorithm, advanced encryption standard, and the key, which key? Secret key or shared key, which is 1, 2, 3, 4. Now she will be generating this encrypted file. What exactly inside this encrypted file? Can anybody tell me? Of course, if you are successfully able to decrypt it, you are going to get original file as well as fingerprint, because this is what you are encrypting with this algorithm and key. There is no doubt about it that Mr. Intruder will not be able to open it. Why? Because Mr. Intruder can know what was the algorithm, which might be AES, but he doesn't know what is the key value. Basics of encryption, guys, right? Really interesting. Now, this message will be delivered over internet from here to here. If that is the case, what Mr. Rahul is going to do? Mr. Rahul is going to decrypt this message with what? With algorithm advanced encryption standard plus key value of 1, 2, 3, 4, which is the shared key or the secret key. what he's going to get? He's going to get the file content or maybe data or the complete file plus fingerprint. And now Rahul also know that when Anjali start with the communication, she hashed it with Shah. He will be passing this file to the Shah. He'll be getting this fingerprint and he will be matching this fingerprint with this one. If both are same, Mr. Rahul is absolutely sure that nobody has changed this message in middle. Isn't this process is mind-blowing, guys? Really interesting, right? Now consider a situation in which Mr. Intruder come into picture and Mr. Intruder is saying, of course, I cannot read this because I do not know the secret key, but I can change the content of it. But here is the problem. If we change the content, what is going to happen? If we change the content, then the result, when Mr. Rahul decrypted, these results are going to be changed. Maybe this is also going to be changed. If that is the case, this guy will be decrypting it, matching it, and really interesting what you are going to see. If these two numbers are not matching, Mr. Rahul will come to know that yes, there is something, somebody is in the middle who has tweaked this file, who has changed the content of this file. And if that is the case, Mr. Rahul is going to discard this message. So what we have just achieved here, we have just achieved confidentiality. We have also achieved integrity of the message. If these hash values are not matching, then there is a problem. If these hash values are matching, then basically we have integrity of the message. We have maintained integrity of the message during the communication, right? Have a look at this picture, guys. Just try to digest it. If anything which is not making sense, I am here. Next 5 to 10 minutes, we are going to discuss only your question.